Today we'll see the derivation of distance formula, one of the beginning topic of coordinate geometry. So what is a coordinates? A coordinate could be defined as the values or a set of values that shows an exact position of point or a set of points. On graphs, it is usually a pair of numbers. Let's consider a Cartesian plane. As you know, a Cartesian plane consists of x-axis and y-axis. Horizontal lines are called x-axis and vertical lines are called y-axis. The intersection of x-axis and y-axis is called origin. The horizontal markings right from origin is positive x-axis. So these points we say is +1, +2, +3 and so on. Similarly, the horizontal markings towards left of origin is called negative y-axis. So these numbers can be denoted as -1, -2, -3 and so on. The set of points above origin is positive y-axis, 1, 2, 3, 4 and so on. Similarly, the set of points below origin is negative y-axis. We denote -1, -2, -3 and so on. If I want to represent a point, say 4, 2, which is also called as a coordinate, hence it comprises of two components, x component and y component. So here 4 represents the horizontal distance and 2 represents the vertical distance. Always the horizontal distance is written first. Since the x component is positive, so from origin we go towards right. How many units? 4 units. 1, 2, 3, 4. So x component is 4. Similarly, y component is 2. So from here 2 units up, y up because y component is positive. If it was a negative, we need to go down. So 1, 2. Hence collection of x component and y component separated by comma and closed under a small bracket denotes a point or a coordinate in a Cartesian plane. Do you know who is father of coordinate geometry? Yes, he is none other than famous French mathematician René Descartes. Actually, this coordinate geometry, or in other words we say analytical geometry, was independently invented by Pierre de Fermat and René Descartes. Although Descartes is sometimes given sole credit, the alternative term used for analytical geometry is Cartesian geometry also. Now let's come to the derivation of distance formula. Let's consider a point A, x1, y1 and B, x2, y2, where D represents the distance between these 2 points, that is AB. Now let's draw AM perpendicular to x-axis. Similarly, BN perpendicular to y-axis and AP perpendicular to BN as shown in the figure. So friends, I think you know what to write. The same thing that I said earlier you need to write here. Now you see in the figure, in right angle triangle APB, how much will be AP? Can we say ON minus OM? Of course, it is yes. Since point A is x1, y1, that means ON should be x1 and AN should be y1. Similarly, the point B is x2, y2. So ON is x2 and BN is y2 respectively. So now tell me how much is AP? AP is x2 minus x1. x2 minus x1. Similarly, BN minus PN will be BP, that is y2 minus y1. So this you can mention in the figure. As you have written here in right angle triangle APB, directly you can write AP equals to ON minus OM, that is equal to x2 minus x1, and similarly BP equals to BN minus PN, which is equal to y2 minus y1. So friends, now you know Pythagoras theorem. Since there is a right angle triangle APB and you know wherever right angle triangle is there, always Pythagoras theorem is used. If you don't know about Pythagoras theorem, then I have made a video on Pythagoras theorem. You can see that video. The link is given in the I button up. You can see now there. After watching that only you come here if you have any confusion regarding Pythagoras theorem. But also let's recall Pythagoras theorem. Longest side square equals to sum of square of the remaining 2 sides, isn't it? So let's write that. Friends, we can write or not. AB square equals to AP square plus BP square. This we have written from Pythagoras theorem, okay? Or AB equals to, you know, square opposite is always plus minus and then root under. But here we do not give plus minus because distance is always positive. So simply root under. Now AP is how much? x2 minus x1 whole square plus BP is y2 minus y1 and its whole square root under. So this is our formula, friends. So this formula is derived. Isn't this formula easy? So what you felt about the video, you please comment in the comment box, and in our next video we'll see the derivation of section formula. Okay, thank you.